All right, cool. We are now on to, go away. There we go. The enthalpy calculations part 2, the second version. So in this version here, we are working in the other direction. We are going from energy to grams is the way I like to call it. So that's our fourth version, energy to grams. And I'll show you an example of that. So when we look at this question over here, what we can see is they've given me an equation again. They've given me the delta H, but in this case, they're asking me how much mass of silver will be produced if 555 kilojoules of energy is absorbed. So slightly different way that they're asking it, but basically we're doing steps sort of in reverse. So what I'm going to do is I'm going to pause the video and hopefully remember to unpause it before I start talking, and we'll work our way through it. I just need to copy this down first. Okay, cool. It's definitely recording now. All right, so let me do that again. Let me do this again. All right, now we're moving back. Move that out so you can see the steps again. Go back. Oh dear. There we go. Now you can fit it. There's fewer steps for this one. All right. So in this question here, they have given me the amount of energy. In this case, they're saying this energy is absorbed because I can tell that's an endothermic reaction. And now they're asking how much mercury is being produced. So how much, when we see a question like that, they're asking about grams. So that's why I like to say that this one is an example of going from energy to grams, because we have the energy as our first bit and we're working our way to grams. Again, what we need to be mindful of is that when we're looking at this equation and we're given this enthalpy value is in reference to 1 mole of the equation. We, again, need to pay attention to what they're asking us to solve for, because basically what that is telling us is that for every 2 moles of mercury, this is how much energy is going to be absorbed. So we see in that first question here is that we need to divide the coefficient of the unknown mass that you're solving for take the enthalpy and divide it by the coefficient, because that's telling us then how much kilojoules is released for 1 mole. So again, let me show you what I mean. So if I have 2 moles of H2 being produced, that based off of my equation is going to require 182 kilojoules. Now we want everything in kilojoules per mole, so 1 mole. So since this is 2 and that's what 2 moles is going to be produced, if I want to know what 1 mole is going to be produced, I just need to divide that by 2. So 1 mole of Ag or Hg divided by 2 is 91 kilojoules. So you can see here, I've basically just divided it by 2 to get that answer. All right. Next thing I then do is I take this value, so 91 kilojoules per mole, and I am then going to take how much energy that's being produced and multiply them together. No, lied. I'm going to divide them. So the reason why is this is how much energy is going to be absorbed, and I divide it by the kilojoules per mole. So that way, again, I get back to just mole by itself. So 555 kilojoules divided by 91 kilojoules per mole. And you can see why I say, make sure you pay attention to your units, because that is how I caught my mistake. So kilojoules and kilojoules cancel out. I have per mole, so that makes it mole. So if I just do 555 divided by 91, I get 6.09890, and there's lots of numbers behind it, but I probably won't need them because I'm going to be rounding 3 sig figs at the end. Actually, no, not at this point. So that's my moles. But we need to convert back to my mass. So if you guys remember this equation, N equals M divided by big M, moles equals mass divided by molar mass. I want to rearrange this equation to solve for M. So to solve for M, I need to do little n times the molecular mass. Unfortunately, they only give you this format of the equation, so you do need to know how to rearrange it. Worst case scenario, just plug in the numbers, and whatever you don't have, just work your way to whatever the x variable, if you don't know how to rearrange to like that. All right, so m is equal to 6.06 ... moles times the molecular mass. Now, in this case, because we're talking about mercury, I want the molecular mass of mercury. So I'm just going to quickly Google that because that's one I do not have memorized, which isn't really a surprise because we don't use mercury all that often. And that's 200.59 grams per mole. Not surprising. It's a very heavy metal. All right, so again, check. Moles cancel out. I have grams left over. So if I did that reaction, what I should get is 1,223.348, and there's lots of little numbers behind that. I want to do 3 significant figures, so 1, 2, 3. That's my significant figure. I look over there, that's a 3, so I'm going to round down. So my answer would be 1,220 grams of Mg will be produced. And that's how I convert from my energy to grams. So just working in a different direction.